Welcome to MRL. In this learning session, we'll be learning about the concurrent lines and concurrent points of a triangle. The various concurrent lines of a triangle are the altitudes, medians, angle bisectors and perpendicular bisectors. And also we have the different concurrent points of a triangle. They are the orthocenter, centroid, incenter and circumcenter. Also remember that with the help of incenter and circumcenter, we can draw two types of circles to a triangle. One is the incircle and the circumcircle. Let us learn all these points in this learning session. Now let us start with the first important concurrent lines of a triangle, that is the altitudes. Now before we start with the altitudes, let us understand what is an altitude. The altitude of a triangle is the perpendicular drawn from a vertex to the opposite side. A perpendicular drawn from the vertex to its opposite side. Therefore AD, which is perpendicular drawn from the vertex A to the opposite side BC, is the altitude. Rather, AD is the altitude of the triangle ABC. Now we know that our triangle has three vertices, therefore three altitudes can be drawn in a triangle. So accordingly we have got AD is an altitude, BE is an altitude and CF is an altitude. And all these three altitudes pass through have a common point or pass through a point, and therefore the three altitudes of a triangle form the concurrent lines of a triangle. The point where the common point or the point through which all the three altitudes pass is known as concurrent point or point of concurrency. And therefore the point of concurrency or the concurrent point of altitudes is known as orthocenter, and it is represented by O. So therefore remember, the orthocenter is the concurrent point of altitudes or point of concurrency of altitudes. Remember that. And the position of the orthocenter is different for different triangles. For an acute angle triangle, the orthocenter is inside. For a right angle triangle, it is at the right angled vertex. Remember that. And for an obtuse angle triangle, it is outside the triangle. If you take this triangle here, we have the triangle ABC, which is an obtuse angle triangle. If you draw the perpendicular that is altitudes to triangle to the sides of the triangle ABC and produce them backwards, they meet at a point O, and that point O is called as the orthocenter of the triangle, which is an obtuse angle triangle. So like that, orthocenter position is different for different types of triangles. Remember that. Now the second important concurrent lines are the medians. Now let us understand what is the median first. The median of a triangle is a line segment joining a vertex to the midpoint of opposite side. The very important thing here, the median of a triangle is a line segment joining a vertex to the midpoint of opposite side. For example, now if you take a triangle ABC, A is the vertex and D is the midpoint of BC. When I join AD, then AD is the median. AD is the median. So please remember that. Now a triangle, as you know, that has three vertices. A triangle has three vertices, therefore three medians can be drawn in a triangle. We have the median AD, we have the median BE, and we have the median CF. Therefore there are three medians which can be drawn to a triangle, and all these three medians pass through a common point, and that common point is known as the point of concurrency or the concurrent point of the medians of a triangle. Is known as the concurrent point or concurrent point of concurrency of the medians of a triangle. And this point of concurrency of medians of a triangle is known as a centroid. So therefore remember, centroid is a concurrent point of the medians of a triangle. Now the centroid divides the medians in the ratio 2:1 with the longest part near the vertex. It's a very important thing to remember. The centroid divides the median in the ratio 2:1 with the longest part near the vertex. The centroid is interior to the triangle and is located at 2/3 the distance from each vertex along each median. So for this centroid is divides the median AD in the ratio 2:1, and so also the other medians are divided in the ratio 2:1, and the centroid is at a distance of 2:1 from each of those vertexes, that is A, B and C. Remember that. Now the next important concurrent lines are the angle bisectors. What is an angle bisector? An angle bisector is a line segment that bisects an angle of a triangle and then intersects the opposite side. Now let us take the triangle. For example, in triangle ABC here, AD is the angle bisector because it bisects the angle A and intersects the opposite side BC. Therefore AD is the angle bisector. Now in a triangle there are three angles, therefore the three angle bisectors can be drawn to a triangle, and the three angle bisectors AD, BE and CF have a pass through a common point I, and that point I is the concurrent point of the angle bisectors, is the concurrent point of the angle bisectors of a triangle. So therefore remember, the point of concurrency or the concurrent point of the angle bisectors is called as the incenter. That is the incenter, that is the incenter, and is represented by I. And the incenter, if you see here, the incenter, it is inside what you call in an acute angled triangle. It is an acute angled triangle, it is inside the triangle. Now the incenter for all triangles is inside. That means it's very clear, the incenter is always, remember, inside for any triangle, whether it is acute angle triangle, right angle triangle or obtuse angled triangle. And with taking the incenter as the center and the radius IF, that means the radius IF or the radius or the center of circle that can be drawn inside the triangle touching the sides of a triangle, the circle drawn is called as incircle. The meaning is, if you take the incenter as the center and draw a circle touching all the three sides of the triangle, then that circle is known as the incircle. And the incircle is a circle circumscribed by the triangle. The radius of the incircle is known as inradius. If you see here, IF is the radius, then this is called as the inradius. This is inradius, this is incircle, and the I is the incenter. So therefore remember, to draw an incircle, we have to locate the incenter. To locate the incenter, we have to draw the angle bisector and locate the incenter. So that is what is the one of the important circles which can be drawn within a triangle by the help of incenter and by drawing the angle bisectors. Now the next important concurrent points lines are the perpendicular bisectors. A perpendicular bisector is a line segment that passes through the midpoint of the side of a triangle and is also perpendicular to the side. Let us understand this. In triangle ABC, BC is one side and PQ is the perpendicular bisector to side BC. That means it is not only perpendicular to BC but also it divides BC into two equal parts. Rather, D is the midpoint of BC, that is BD is equal to CD, and PQ is perpendicular to BC, and therefore PQ is known as the perpendicular bisector. Now in a triangle there are three sides, therefore three perpendicular bisectors can be drawn, and all these three perpendicular bisectors pass through a common point, and that common point is known as the concurrent point of perpendicular bisectors or point of concurrency of perpendicular bisectors, and the point of concurrency of perpendicular bisectors is known as the circumcenter. So the circumcenter is the point of concurrency of the perpendicular bisectors of a triangle, and it is denoted by S. Now remember, the circumcenter is the what you call inside the triangle for an acute angle triangle. It is in the midpoint of the midpoint of the hypotenuse of a right angle triangle, and it is outside the triangle for an obtuse angled triangle. Now taking the circumcenter as the center and the distance from the center to any of the vertices as the radius and draw a circle, then we find that the circle passes through all the three vertices, and this circle is known as the circumcircle. So therefore remember, the circumcircle is a circle which passes through all the three vertices of a triangle. When we take the circumcenter as the center and the distance from the circumcenter to any of the vertices as a radius, the distance from the circumcenter to any of the vertices is known as circumradius, and the circumcenter is the center of the circumcircle. So please remember these points. So these are the important what you call concurrent lines and concurrent points of a triangle. Very important for us to remember basics. These are the basics in geometry, useful in geometrical calculations. Learn them, remember them, and make a note of it. Thank you.